Okay, hello everybody. I'm going to talk about one very specific PEC, which is a chair with heating and cooling function. The motivation to develop this chair was, of course, that the perception of people, the thermal perception of their environment can be very different, as you can see in this picture here. So one can feel very cold in the same environment where someone else is feeling hot. So in order to make all of these people happy, there's a need of integrating a way to provide thermal comfort by a heating and cooling function. So this was done with this chair, and this was the main driving point. But of course, the second important motivation was to achieve a reduction of energy consumption by extending this HVAC deadband. So we already showed one of the graphs where you can see if you lower the set point for heating here, for example, from 21 degrees C to 19 degrees C, or the set point for cooling, you raise it from 24 to 28 degrees C, you can achieve significant reduction of energy consumption. So this is the background for this chair. And here you can see the one that we investigated, and this was a very first prototype. Today, this is a commercial product which you can buy in any kind of color, any kind of fabric. So how does it work? The heating function is through heating wires, and this IR rendering shows you how they are placed here in the seat of the chair and in the back of the chair. And of course, they work by reducing the heat loss from the body to the environment by providing a temperature very close to your body temperature. The cooling is not an active cooling. It's provided by little fans, so increasing the air circulation around your body by increasing the convective heat loss from your body to the environment. In addition to the sensible heat loss of the body, this increased ventilation has the advantage that it dries your skin, so it makes the sweat, the humidity on your skin evaporate and provides a cooling effect through this evaporation. So how does it work? You can see here this box and several buttons. So here we have, first of all, a rechargeable battery, which of course is required to provide electric power. Needs to be recharged something between every day to every other day, depending on how often you use it. You have two buttons where you can choose heating and cooling function and even different levels of intensity. There's a pressure sensor integrated in the chair, so when you get up, every function will be switched off. Let's look at the energy or power. It's very energy efficient, ranging from 2 watts for cooling in level 1 up to 12 watts for heating in level 2. So we did a field study in this relatively modern office building built in 2010. Quite large windows, exterior shades that were manually operated with operable windows and no air conditioning at all. The facade that you can see here is a southeast orientation, and then of course on the backside you have northwest orientation. And we ran this field study from mid-July through mid-October 2015. Altogether, we had 26 participants, 10 female and 16 male. Average age was 39 years, so typical office workers. And we requested them to participate for a duration of at least 5 days. And the average duration that participants would use the chairs that we gave out to the participants was 21 days. During the days when they used the chair, they were requested to fill in an online survey twice a day at 11 a.m. and at 3:30 p.m., where they rated their thermal sensation and thermal comfort before using any of the cooling or heating function and afterwards. And we used an extended 9-point sensation and 8-point thermal comfort scale. So during that time of the field study, ranging again from, as I said before, from July 15th to October 18th, we had a really hot period in July and August. It was a very hot summer in all of Europe and in Germany in particular. And here the yellow curve shows the outdoor temperature, and you can see that until mid of September, the temperatures rarely fell below 20 degrees C, so there was not a lot of night cooling, but there were air temperatures up to 38 degrees C. The green and dotted blue line are temperatures from 2 example office rooms. And here you can see that very often the air temperature in the rooms was at 30 degrees or even beyond. Please ignore the couple of extreme peaks here. They occurred when the direct sun hit one of the the temperature sensors, happened especially on the west facade. So these peaks were extreme. They were not correct, but even without these peaks, you can see there were high temperatures in the rooms. So before we gave the chairs out to the participants, we integrated a logging function in order to control or to monitor how the participants would operate the chairs. So here you can see this was one participant. He used the heating function of the chair for 3 days here. Then here 3rd of October is a holiday in Germany. Here was a weekend. And then again, Monday, Tuesday, Wednesday, he used the chair and he switched between heating level 1 and heating level 2. So here are the votes. Sorry, it's a little bit slow. Here are the votes from the online survey. And first of all, let's look at the sensation when turning on the heating function. So this person rated that he could improve his thermal sensation from a cool or cold state to at least neutral or even slightly warm. And he stated a very clear increase in thermal comfort from uncomfortable to clearly comfortable. So for the heating functions, we didn't have that many votes because the period was relatively short when there was heating conditions. But out of the 67 votes that we got, 85% stated an increase in sensation, thermal sensation. So they became warmer, they felt warmer. And 64 said that this led to a clear increase in thermal comfort. As we recorded the room temperatures in all of the rooms where people would use chairs, we could tell that an acceptable room temperature was still possible at around 19 to 20 degrees C if people were provided with these chairs. However, below 19 degrees C, people would complain about cold heat and cold and cold hand. So below 19 degrees C, people would complain about cold extremities. And I think Hui's presentation before clearly explained this fact. For temperatures below 90 degrees, we definitely recommend foot warmers, as you could see in the presentation before. Okay, very briefly, operation of chairs for the cooling mode. Here we expected a decrease of thermal sensation, and this participant also made clear that he felt cooler with using the cooling function of the chair, and again, a very clear increase in thermal comfort. We had more votes for the cooling function due to this longer period of hot weather. However, the results were a little bit less positive than for the heating function. So about a third of the people could really tell that they felt colder using this cooling function, and had an improve of thermal comfort due to the use of the chair. Again, when looking at the room temperatures, the upper limit of when people would still feel comfortable with using a chair with cooling function was around 29 to 30 degrees Celsius. So here the recommendation would be to use tabletop fans to cool the head. So here there's a short summary of the results again. So basically a third of the people really liked the cooling function, and more than 80% enjoyed the heating function during colder conditions. Okay, so these were the results from the field study. And now I want to briefly go through a recent approach that we did for investigating the effect of the chairs. And this is a modeling approach for which we used thermophysiology model together with Hui's sensation and comfort model. So this physiology model had body divided into 16 body parts, and we coupled this thermophysiology, sensation and comfort model with a building simulation software with ESPR. And we had a input-output exchange at any time step. So through this coupling, we could integrate the reactions, the thermophysiological and sensation and comfort reactions in a controller of the HVAC system that we ran in the building simulation. We modeled an extension of the deadband as well as different PECS systems. For example, the chair was modeled by adjusting the equivalent temperature, which is one of the determining variables in the physiology model, varying by a certain correction factor, plus or minus 4 Kelvin. These were values that we got from measurements. Or we adjusted for the cooling function, we adjusted the air velocity around the body. Here is an overview of the results, and I cannot go into detail to the limitation of the 15 minutes. But what I can say from this very extensive study was that the chair always got good results in terms of maintaining thermal comfort. So even with extending the HVAC deadband, we could still have very good values for thermal comfort. And for certain conditions, we could achieve an energy reduction. Sometimes it was rather small, but for example, together with a desk fan, we could achieve energy reductions from 8 to 15% in summertime when using the chair with the cooling function. Okay, so to conclude the presentation, the field study really showed promising results, especially for the heating function, a little bit less in cooling mode. Here we found that just some people didn't like it that much, felt more like a draft in the back. But overall, it was still promising. And the modeling approach showed potential to reduce energy consumption while maintaining thermal comfort. And there's certainly still room to improve the modeling approach to be more precise and to validate it by comparing it against experimental results. This chair has been developed as a commercial product, so it's available, you can buy it now. But there were kind of significant barriers for greater market penetration. And I just recently wrote a commentary, and for this commentary I discussed all these barriers with the manufacturer. The chair was put to market in 2016, so now they have an experience of 6 years. It wasn't so easy to get this chair promoted and sold. However, especially with the energy crisis due to the war in Ukraine, in Europe, I see a big potential for this chair in the future, in this winter. For example, in Germany, the public buildings are now heated only up to 19 degrees Celsius. 19 degrees Celsius is a temperature where not a lot of people feel really comfortable. And here, a chair with heating function could be really a solution to get through the winter in a relatively comfortable way. Okay. Thank you very much for listening.